Our cosmic neighbors, the Sun and Jupiter, our Sun. It's the star of our solar system. It sits right there in the center. Everything else goes around it. The Sun gives us light and warmth. Life on Earth depends completely on the Sun. Without it, our planet would be a frozen dark rock. This magnificent star is a giant glowing ball of incredibly hot gas. It's been shining for billions of years, and it will shine for billions more. Then there's Jupiter, the king of the planets. It's enormous. You could fit all the other planets in our solar system inside Jupiter and still have room to spare. Jupiter has swirling clouds and giant storms. One storm, the Great Red Spot, is bigger than Earth itself. Jupiter also has many moons, more than 75 last time we counted. It's like a mini solar system all on its own. Now let's get to a wild idea. What if we could take Jupiter, this giant planet, and feed it to our Sun? Yes, you heard that right. Use Jupiter as fuel to refuel the Sun. The great cosmic delivery moving a giant planet. Moving Jupiter is an unbelievable challenge. It's mind-bogglingly difficult. Jupiter is incredibly massive. It weighs more than 300 times the Earth. We currently have no technology that could move such a colossal object across the vast distances of space. This is purely a thought experiment. So, let's suspend our disbelief for a moment. Let's imagine we could actually do it. What would it take? How could future humans, or perhaps some super-advanced alien civilization, achieve such a feat? Maybe they'd build unimaginably large solar sails, using the Sun's own light to push Jupiter. Or perhaps they'd master gravity manipulation, creating gravitational tugs to slowly alter Jupiter's orbit. Another idea could be a series of precisely timed asteroid impacts. For our cosmic query, let's just assume the delivery is possible. The package, one gas giant, is on its way to the Sun. Fun fact. Jupiter is so big, it's 2.5 times more massive than all the other planets in our solar system combined. Stellar Kitchen, how stars cook, and what Jupiter brings. Let's talk about the Sun's engine. What makes it shine? Deep within the Sun's core, conditions are extreme. The temperature is about 15 million degrees Celsius. The pressure is over 200 billion times Earth's atmospheric pressure. In this cosmic furnace, hydrogen nuclei, protons, are forced together. They overcome their natural repulsion and fuse. This process is called nuclear fusion. 4 hydrogen nuclei eventually combine to form one helium nucleus. The helium nucleus has slightly less mass than the 4 hydrogens. That missing mass is converted into pure energy. Now what about Jupiter? What are its ingredients? Jupiter is primarily composed of hydrogen and helium. About 90% of its atmosphere, by volume, is hydrogen, and about 10% is helium. Does this composition sound familiar? It should. It's very similar to the Sun's composition. So, Jupiter has the right kind of stuff. The raw materials that stars use for fuel. Section 4, Collision Course. Jupiter meets the Sun. Imagine Jupiter on its final journey. It's being nudged towards the Sun. The Sun's immense gravity takes over. Jupiter accelerates. The Sun's gravitational pull is incredibly strong. Jupiter's gravity is no match for the Sun. Tidal forces stretch and deform Jupiter. It heats up dramatically from the Sun's radiation. Jupiter would be torn apart before reaching the Sun. Its gases form a massive accretion disk. Larger chunks might make a direct impact. It would be a spectacular, chaotic, and violent event. The sky would be filled with celestial fireworks. Jupiter would cease to exist, its substance consumed by the Sun. It becomes part of the Sun's mass. Jupiter's legacy is a more massive, agitated star. Section 5, a new solar system, aftermath and cosmic wonders. What would be the immediate effect on our Sun? With all that new material, especially hydrogen falling onto it, the Sun would react. The added mass would increase the pressure and temperature in its core. This, in turn, would increase the rate of nuclear fusion. More fusion means more energy output, so the Sun would likely become significantly brighter and hotter. This wouldn't be a gentle warming. It could be a dramatic surge in luminosity. For any life on Earth, this would be catastrophic. A sudden increase in solar radiation would boil away oceans and scorch the surface. Now for the cosmic irony. You'd think that adding more fuel to the Sun would make it last longer. More logs on the fire, right? But stars don't quite work that way. While the Sun would indeed have more hydrogen fuel, the increased mass also means stronger gravity. This stronger gravity compresses the core more intensely. A more compressed core means higher temperatures and pressures, and this causes the Sun to burn through its fuel much faster. So, paradoxically, adding Jupiter's mass to the Sun might actually shorten its overall main sequence lifespan, not extend it. It would burn brighter but for a shorter time. The consequences for the rest of the solar system would be profound.